Next problem is also from Dixon, which is 4.4. The question is, the combustion gases enter the first stage of a gas turbine at a stagnation temperature and pressure of again nozzle, rotor. This is gas turbine. Okay, so the stagnation pressure is 4, stagnation temperature 4 bar is 1200 Kelvin. Is given the rotor blade tip diameter. Let me draw this. If this is the rotor, these are the blades. Okay, it says that the tip diameter. Here we have another rotor. It says the tip diameter is 0.75 meter. The blade height is 0.12 meter. Shaft speed is n, this is n, is equals to 10500 rpm. At the mean radius, the stage operates at a reaction of 50%, flow coefficient of 0.7, and the stage loading coefficient. This is also known as stage loading coefficient or head HEAD coefficient of 2.5. Okay. So this distance is 0.75 divided by 2. 5 divided by 2. So this distance is 0.375. This distance is 0.06. Okay, half of 0.12. So the mean radius, this is the mean radius, this is equals to 0.375 minus 0.06, which is 0.315. So the mean radius mean is 0.315. Diameter mean, it is into 2, 0.63 meters, right? Now the first question is the relative and absolute flow angles at the stage. So we have to find out alpha. For the relative and absolute flow angles for the stage, alpha 1, alpha 2, beta 1, beta 2, we have to find out all these things, right? Let me draw the inlet and the outlet velocity triangles. This is W1, this is V1, this is U, this is beta 1, this is alpha 1, right? This is outlet V2, W2, this is beta 2, this is alpha 2. So since it is 50%, so we have beta 1, this is equals to alpha 2, and beta 2 is equals to alpha 1, right? This means my reaction is 50%. We have R for a turbine is 5 by 2 cot. Which one is less? Beta 2 is less. cot beta 2, right? Beta 2 is less cot beta 1, and we know the psi phi to cot beta 2 plus cot beta 1, right? R is 0.5 is equals to phi is 0.7 cot beta 2 minus cot beta 1, 2.5, 0.7 cot beta 2 minus cot beta 1. So if we take this over here and if we take this over here, and if we add these two equations, we have 2 cot beta 2 is equals to 0.5 divided by 0.7 plus 2.5 divided by 0.7. Adding these two, right? So we have 4.2857 divided by 2, 1 divided by answer, shift tan inverse. We have beta 2 is 25.017 degrees. Okay, we have to find out beta 1 also. We can put in any equation. Let me put it here over here. Cot beta 2 is how much? 2.143. So we have 0.5 divided by 0.7, 2.143 minus the answer, 1 divided by answer, shift tan inverse of answer is 35. So beta 1 is equals to 35 degrees. So we know all these values, right? And the answer is not matching. I have made a huge mistake. Here it will be divided by 2. I always make this mistake. Very poor. So let me do it once again. So 2 cot beta 2 will be 0.5 divided by 0.7 into 2 plus 2.5 divided by 0.7 divided by 2.5. This is 2.5. Okay, so shift tan inverse. So beta 2 is 21.8 degrees. This is 43.02 degrees. Okay, now the answers are correct. I made a very big mistake, so please be careful. Velocity of at the nozzle exit is the second question. So we have to find out V2. Okay. It's V1. Okay. From all these you can find out U. So U is pi dn by 60 is the formula. We can put this d over here. N is this. So we have pi into d. D is how much? 0.63 into 10500 divided by 60. which is equals to 346.36 meters per second. Okay, now we know phi. Okay, let me do it separately. Now we know phi is equals to 0.7, u is equals to 346.36, and phi is Vx by u. So Vx is equals to 242.45 meters per second. Velocity of the nozzle exists. So we have to find out V2, which is V1 in this diagram, right? We now know Vx. We know alpha 1. Alpha 1 is beta 2, which is 21.8 degrees. Vx is 242. So from this right angle triangle 2.45, we can find out V1. Sine 21.8 degrees. So we have V1 is equals to 652.86 meter per second. Okay, the answer is right. Now we have to find out the static temperature and pressure at nozzle exit. Means the static pressure and temperature at the nozzle exit, assuming the nozzle efficiency of 0.96. So it is given nozzle efficiency is 0.96, and also we have to find out the mass flow rate. Okay, nozzle efficiency of 0.96, mass flow rate, we have to find the static temperature, and also we have to find out the static temperature, pressure and static temperature, right? So let me take the help of the HS diagram. For the nozzle, this is 0, this is 1. This for the nozzle. So we have nozzle efficiency, which is total to static. Okay, so we have T zero one minus T1 divided by T01 minus T2 T2 is T2. So from we know the nozzle exit velocity as this, okay, and T01, we can find out T2 from here. T2 is equals to T02 minus V2 square by 2. This is actually V2, okay, Cp, which is equals to T02 is T01 because there is no energy. Sorry, there is no heat or work transferred across the 1200. Value of CP I'll take as 1160. Okay, so I'll come to T2 from here. One zero one six point two eight Kelvin, right? I will find out T2s from here. Okay, so we can find out T2s. 0.96 is 111200 minus 1016.28 divided by 1200 minus T2s. This is T2s. Okay, now what we can do is that we can find out P2. This is one answer actually of T2. P2 by P01 equals to T2s by P01 to the power of T01 gamma by gamma minus 1. We can take gamma as 1.33. How much is T2s? 1008.626 divided by T01 1016.28. Sorry, T01 is 1200 33. Here is 0.33 P2 by P01. How much is this P01? P01 is 4 bar. Okay, nice, 4 bar. So P2 is It is 1.9859 bar. Okay, now we have to find m dot. We can find out P2 is equals to rho to RT2. Okay, so we can have R as 287.8. So 1 point, so we have from here we can directly find out T2. So we have rho 2 is equals to 0.6789 kg per meter cube. Now m dot is how much? m dot is rho 2 into v2 into a2. Now we know all these things. We only find out a2. A2 is the mean radius, which is 0, or the mean diameter, the perimeter along the mean diameter is pi d into the height. This is the height, 0.12, 0.12, and mean diameter is 0.63. Zero 0.2375 meters square. So we know all these values. V2 is how much? 652.86. 652.86. This is rho 2, which is this 0.6789 into V2, which is 652.86 into the area, which is this. Again, I have done a very huge mistake. How can this be V2? This has to be Vx. Okay, this cannot be V2. This has to be Vx, right? 242.45. V2 is this. Sorry, V2. V2 is this. This cannot be the one. This is 242.45. This is wrong. Two 42.45 into 0.6789 into 0.2375, 39.1 kg per second. Now this is the correct answer.